OSPF, Open Shortest Path First, a widely used interior gateway protocol. This protocol is being developed by Internet Engineering Task Force, that is your IETF, and this is being developed as a replacement for the problems of your RIP, and now it's a open standard protocol. This protocol is basically a link state protocol, which is not the RIP. It was RIP was a distance vector protocol. So this protocol is entirely different from your structure point of view, like how RIP is being developed and how OSPF is being developed. OSPF uses the link states and it runs a open algorithm, that is a SPF, shortest path first, which is a open algorithm for reconvergence of your routing informations. This protocol is really helpful for your fast reconvergence, your scalability to a much larger networks, which is not supportive in your RIP, and very less susceptible to your bad routing informations. That is very important. This protocol cannot give you any kind of bad routing informations. Some of the very key features which OSPF uses, which is very entirely different from your RIP or your EIGRP, is it uses a areas. The structure of your OSPF is entirely dependent upon the area, how the OSPF completely is being a kind of a hierarchical model in which you will be going to have a area. Like normally in your any routing protocols, you have a routers and you will run a protocol over this routers. Here you'll be going to club your routers in a multiple areas and create a hierarchical structure for it. Like for example, you have router 1, router 2, router 3, and router 4. What normally you'll do, you if you have a link between these two, or all of the four, you'll be going to have a routing protocol over these four. But in this, you can create a area that is not a physical but a logical kind of a structure, and you can club your routers inside an area and create a hierarchical structure. In this way, it you will have different areas clubbing all together at different routers. With the help of this, it reduces your CPU and memory of the devices on which you are running your protocol. So once you have a area structure or a hierarchical structure, your the protocol which is being run is being limited to that particular area and not going to utilize the memory or the space or the CPU cycles which the entire protocol being run to all of the devices. It supports a classless. It's a fully classless behavior, emulating your classful problems as a kind of a discontiguous subnets. It supports of your classless routing table lookup, VLSM, and supernetting for efficient address management. It supports the authentications. It's have a inbuilt authentication mechanisms. What is the type of authentications you can use it in your OSPF? From a high level perspective, if we go, so OSPF basically uses various packet formats. So if we understand OSPF from a high level, it's a you enable OSPF on a particular set of routers. They send the hello packets, which is the basic packet, first packet, which they need to exchange out for all OSPF enabled interfaces. If any of the routers or two set of routers sharing the common link agree on certain parameters which is inside of your hello packets, they're going to become a neighbors. So in OSPF you will be going to establish a neighborships before exchanging the routing informations. So it's all about your exchanging of hello packets, matching of certain parameters inside your hello packets, and creating a neighborships. Adjacencies. Once you have a neighbor recognized, you'll be going to build the adjacencies between your neighbors depending upon what type of links you are sharing with your neighbors. So it defines a several network types and a several router types. The establishment of the adjacencies is determined by the type of router exchanging the hellos and the type of network over which the hellos are exchanged. Each router sends a link state advertisement. Here you have a concept of LSA, that is your link state advertisements, which is over all your adjacencies. These LSAs are nothing but a describes all the routers links. Suppose if I have a routers, like suppose I'm having router 1, router 2 and router 3. I'm having a loop back dashed with all of my routers. What I'm going to go is first these routers will be going to exchange the hello packets with each other. Once their hello packets are exchanged and they agree on some of their basic parameters, which we'll see what are the basic parameters inside your hello packets. Once they agree on that, they'll be going to establish a neighborship or the adjacencies. Once your adjacency is built up, they'll be going to share your LSA, each router. So LSA are nothing but your link state advertisements of your link informations. Like this interface is attached to me. I'm having a loopback interface with /32 mask maybe. It shares those informations with its neighbors. A similar way R2 will share its LSA, all the interlinked informations with R1 and R3. In this way, each and every routers will establish a link state database. So each router will have a link state database. That is the that is the fourth point features of your OSPF, that they have a link state database. Now, once they have a link state database, this database will be going to be unique. A very important key point of your OSPF is identical link state database. This link state database will remain used to be unique on a particular area. If this route belongs to a particular set of area, the link state database will be going to be same. Once they establish a LSD, they'll be going to run a SPF, that is your shortest path first algorithm, over this database. Once they run the algorithm, they'll be going to create a tree kind of structure from this graph. Maybe you can have a link like this, so it's a kind of a graph. So each routers will be going to run a SPF algorithms over its LSD, create a tree, and once your tree is created, a routing table will be going to build up from the SPF tree. So this you might be getting very much confused about what exactly this LSD, links to your database, hello protocols, and all those things. But this is just a high level understanding. We'll be going to touch up each and every aspect of it in depth. The main reason for me to let you introduce with the concept of OSPF, so that when we go one by one, you'll be having a high level understanding of OSPF, so that you can visualize what I was talking about, the areas, about the LSD, about the link state informations, so that you'll be able to grab up all those informations correctly. So this is my main point of understanding the OSPF from a high level perspective. So this was your OSPF high level features. We'll meet up in the next section. Thank you very much.